because now it's time for Jonas Anund Fogel to speak about the KTH Living Lab, which is a testbed for accelerated innovation. And this event is recorded, and if you have any questions, please ask the questions afterwards and raise your hand, because I will go around with this mic so that you're also heard in the recording. Okay, please, Jonas, welcome.
Thank you very much. Welcome, everyone. As you heard, my name is Jonas Anund Fogel, and I'm a researcher at KTH and also director of this KTH Living Lab. Jump right into it. So, I'm partly a researcher, and this, you can see a colleague of mine sitting down there to the left, some 70 years ago, and she was looking at a woman. Of course, only ladies are working in kitchens, everyone knows that. So she was doing a study about how many steps that ladies were taking in the kitchens. Because there was a problem in the society where women walked too much. They got damages because they needed to go down the stairs, go to the toilet, bring coal and firewood up to the kitchens and so on. So in order to overcome this problem with too many steps in the kitchen, they did this research. So as you can see, walking from the stove to the sink is quite frequent. That's the thick line. But walking from the stove to the where you bake your bread is not so very common. And I mean, do we have this problem today when people are walking too much? I wouldn't say that. We rather have a problem when people are sitting still too much. But the regulations that we base our production of buildings on are still based on a society that we do not live in. Maybe we should do this research upside down. Look, how can we increase the steps that we take in the kitchen? Maybe that's the society we're living in today. And another thing with buildings, we're around 30 years after, I would say, many other industries. Cars, they have auto brakes, climate control, soon autopilot. What do we have in our homes? We have to manually walk to the window and open the windows to get fresh air into the apartments. I don't know if that's so very smart. We don't have the services, the buildings, they don't produce the services we would like. And still they use around 30% of the energy in the world, and they are responsible for around 40% of the CO2 emissions. Even though they don't deliver the services we want, they only make it possible to stay indoors, not joyful. So now we have a big task here. We're gonna build around 700,000 apartments in Sweden over a period of 10 years. So either we can produce these buildings as Boverket likes, or not likes maybe, but they say that it's okay. We can build old light bulbs, 90 kilowatt hours per square meter. And if we do that, then we need to produce one nuclear reactor or 1,002 megawatt windmills just to give the heating to these apartments that are needed. Or we can produce like this halogenlampa. I hope you understand. It's quite bad. I mean, you don't want them, but they work. They're a bit more energy efficient. And then you can reduce the number of windmills, for example, to half. Or you can do LED lamp and reduce this by tenfold, the energy use connected to buildings. And these, you can find these on the shelves in the stores. And you can find the solar PVs, heat pumps, connections between these systems, hot water storage, electricity storage. You have everything on the shelves. You just need to know how to connect these systems in order to make buildings a bit smarter and more sustainable. But it seems like the developers, they do not know this, or they don't care. So I started, now it's my 45 minutes of fame here, so I can talk a bit about my research. So I did a study first a few years ago and found 37 barriers to why we don't do this, to why we don't produce smart buildings. Yeah, of course we could found a bit more, I guess, but around 37 it got saturated. I didn't find any more information. So I started the task of trying to overcome a few of these. So let's start with the first one. Cooperative form. Condominium Act. Bostadsrättsformen in Swedish. Almost half of the apartments in Sweden are owned in cooperative forms. And I mean, it's a quite good idea that we own things together. So in 1930s, they did this Condominium Act where people could go together, form a cooperative, and buy some land and produce a building that they hopefully liked, and then live in this apartment. But then society changed, and all of a sudden we have venture capitalists and big companies forming cooperatives, creating an interim board. They're sitting in the board, and then they're putting up a house on this land that this cooperative has bought, and this building is only based on short-term profit. Because once it's built, then the interim board steps away, and the new owners, the users, you guys, they jump into the board, and then the developer, the company, is freed from all liabilities on how they produce this building. The company that produced the cooperative and the building has no incentive of producing a long-term sustainable building, because they don't earn if you reduce the operation costs, because they are not part of that part. So how can we change this? Because this leads to that we put a lot of bad technologies into buildings. For example, this tunnputs, thin plaster on the facade. I mean, almost no building that is rental has these production methods, only cooperatives and single family buildings, because it's cheap and really bad. So if you own a building over a long term, you don't do this. Of course, the professionals know that and knew that, and that's why a lot of people that owns apartments in cooperative forms has these problem buildings now. So in this study, I, together with Hans Lind and Per Lundqvist, we propose 4 changes in how we can produce buildings in cooperative forms. Either start with this, the basic idea from 1930s that we give more power to the people that actually are sitting in the long-term development, a long-term ownership of the cooperative, or limiting the type of companies that can actually form cooperatives. So maybe it can only be serious companies that can form a cooperative. And if you're not serious, then you cannot form a cooperative, only produce the building. Or introduce an official representative in the interim board, seeing that all the decisions that are taken are actually sound and solid, leading to long-term, smart, sustainable buildings. Or somehow more difficult way to increase the information about the building, so that the people that are buying apartments knows what kind of appliances do we have, what kind of technical systems, and so on. But this, of course, is quite hard to educate everyone in building technologies, so there could be a mix of these changes as well. Another example to why we don't produce smart and sustainable buildings are the general conditions of contract that we use here in Sweden. The general conditions of contract are designed that you work with your field. If you work with sanitation, you have the responsible for the sanitation system, and if you is also the heating system, as you can see in the picture. We have wastewater heat recovery systems taking the heat from the sanitation from the wastewater and putting it back to the heating system. We also put this heating into the ventilation system, so the heating system and the ventilation system is also the same system. What happens with incentives, with responsibilities, when you start to mix technical systems? I mean, these general conditions of contract are quite nice, 30 years ago when buildings were not so connected. But now we can control everything and we connect everything. And that's when we do that we reach long-term sustainable buildings. But these conditions of contract, they lead to that the consultant proposes new technology is responsible for the outcome of the techniques. They're responsible for risk for time delays, and they're responsible, they risk being out of compensation if something happens due to the technology they propose. But there is no incentive for the consultant to actually propose new technologies. So I mean, why should they do that? Of course they don't. So that's why we build dumb, crappy buildings. But yeah, I'm writing about this now, so you will soon get the answers to this, But meanwhile, while this document is still the document that everyone almost works with, we're of course trying to make new technology well proven directly, so that consultants can propose techniques without being risks being liable for damage and so on. So that's my third example, and this leads to the KTH Living Lab, that we need to show that new technology is working better than old technologies, or not. That's what we are also going to show. But as an example, the innovation pace in the built environment is really slow. So we introduced water-based radiators, as you can see around here, almost 100 years ago, and it's still the main way of heating buildings in Sweden. But then we introduced better windows, more insulation, and heat recovery systems. And all of a sudden, those stepwise reconfigurations led to radical innovation, that we can take away a whole technical system. When we take away the water-based radiators, we can also put furniture close to the windows. We can make the livable area in apartments bigger without making the house bigger. So this means that every little step we took, better window, more insulation, heat recovery systems, it makes the house more expensive, but it also makes the energy performance better. But then at a certain level, we can take away a whole technical system. As you can see here, the red, I don't know if that's visible here, but the red dots here are all the radiators in this building. They cost around 5,000 per apartment, 5,000 euros per apartment. And we can instead put that money on better insulation, windows, and increase energy performance and decrease cost. So to do that, we need to have demonstration projects. That's what KTH Living Lab is here. We're a closed niche. We have building permit-free area, so we can test technologies in systems and see if they work together or not. As you can see, some of these dots goes out. We should not go on with them. That's what that means. But if we can see that new technology is working in systems, then we can propose to put them into normal buildings, and hopefully we can then transform how buildings are used and produced, and then we can also influence the regulations, the rules, the norms. So that's how we think that KTH Living Lab can transform the way we use and produce buildings. Oh, not working. I think this is the last slide with text, then mainly pictures, if that's better. So, how can we couple demand and sustainability? We need to do that in order to make developers propose and build long-term sustainable buildings. We need to see to that innovative technologies are tested and accepted in order for consultants to propose these technologies. We also need to demonstrate that they work in real systems in order to make contractors choose the technologies and know how to install them. We also need to make researchers continue to develop new technological systems, and in the end also show results to municipalities, to authorities, Boverket, in order to change the way we regulate buildings. No, a bit more text. The first one, how can we couple demand and sustainability? Mats Wilhelmsson on KTH Fastighetsekonomi, he just did a survey study of the value of building a green building, not a smart building, this is only a green building. So you can see that the value premium of a building increases around 18% and the rent premium 11%. That means that you can get a higher rent per square meter and a lower risk for producing and owning a green building compared to normal building. And Mats, he argues that a smart building, these numbers could increase a bit, mainly due to the fact that smart buildings are prepared for what is coming. People that use and live in buildings will rather soon start to demand a bit more than just being able to stay indoors. Maybe they demand 21 degrees indoors, not variation between 17 and 25. Maybe they demand air in the apartment, not to breathe in the same old air that you have breathed a few times. So, I mean, smart buildings are prepared for what's coming. Selling electricity and energy between buildings, being part of the smart system. If you haven't prepared this with valves that you can change, with heating and cooling systems and ventilation systems that can talk to each other, then you will need to rebuild the buildings in a few years. So in order to show this for developers, we have started KTH Living Lab. So KTH Living Lab is a platform handling multiple testbeds, but we're mainly focusing on this testbed KTH that I'm going to talk mostly about here. But we're right now in the process of actually combining a few building systems, the building automation systems, into one database, so that students, researchers, companies can access the KTH Living Lab database, work with figures and data from different buildings, and try to optimize both control algorithms and communication and whatever. Everything to make buildings more smart and sustainable. So this is testbed KTH, 300 square meter building permit free area. So it's situated here on Malvinas väg 14, close to the Q building, Q restaurant. And the idea with this testbed is that it should be possible to do whatever research that we would like to do. So we have an explosion-proof basement. There was a demand from the researchers on energy technology. And then we have space underneath the apartments, 40 centimeters, and almost 2 meters above the apartments. So the whole space is flexible with sprinkler system, so we don't need to take the fire regulations into account. So right now we have 4 apartments here, but we can make up to 8 apartments here. And I also see that we have 3 of the persons living in the 4 apartments visiting us here, so nice that you're listening. So the testbed Einar Mattsson, as you can see, we have the testbed KTH. It's located here. And then the testbed Einar Mattsson is the rest of the 305 apartments. So we can do bigger studies here on behavior and sustainability and so. So we get all the data from the 305 apartments. And we can see electricity, CO2, temperature and hot water and so on in all these 305 apartments as well. But these buildings are also a demonstration project, just to show that we can build this plus energy building instead of an old light bulb. So Einar Mattsson put 1,150 square meter solar PVs on the roof, combined them with 3 rather big heat pumps that are connected to 3,600 meter boreholes divided into 12 holes. And they generate heating when the sun is shining, of course, and then store the heating in hot water tanks. Then they have a preheated air going to the apartments, so no radiators, and a heat recovery of up to 90% of the heating. And then apparently, according to Einar Mattsson's research, not KTH's research, students, they shower twice a day. Is that true? I've never heard anyone say yes about that. Maybe it's 3 times. I don't know. But so a lot of hot water is used in these buildings, apparently. 305 apartments. And so there are 64 wastewater heat recovery systems placed out in the buildings. And they extract around 50% of the heating from the wastewater and preheats the cold water in the shower. So the cold water in the shower is never really that cold that it's in normal apartments. So a day when you're really hungover, you need to take the sink instead. This leads to plus energy building, and that means that it generates more energy over the year than it uses. But it's a surplus during the summer, and then you buy electricity during the winter. Then we have connected with Nordic Choice Hotel, their Hotel Hobo here in central Stockholm. So here it's perfect to do research when you need a big exchange of persons. So we can do a research project in a hotel room, someone moves in, and the next day that person moves out. And then you can twist the research project and then continue doing the same research. So it's 201 rooms, and here they're focusing on water usage, of course, ventilation, but also on these USB-C and low voltage systems. Testbed Akademiska Hus, the education building, Undervisningshuset, down here on campus. So it's also, there are very many sensors here in this building as well, also in the concrete to measure moisture in concrete and movement in the structure and so on. But all the installations are visible, so the whole building should be part of education. So you can both be in the building and use it for education and research. So we're in the middle of connecting this building, of course, as well to our database, so we can both get access to what's happening and to be able to control the building from KTH Living Lab. The idea is that students, anyhow, in the testbed KTH, they move in August, and then they stay in the apartments until May. So companies and all the courses and so on are following the yearly cycle here from autumn to spring. First, do research on how new technology can be put into the apartments, and then handing that information to the project team that actually develops next year's apartments. And then also we have courses following the apartments, looking at how they perform, if there's something we should change. So we had a course a few years ago how we were supposed to design the first 4 apartments. And this was a student from architect school that designed the layout that we have actually built, Cecile. So as you can see, by sliding a few walls, there is a possibility to have a public space and a private space. So if you slide the walls closed, then you have your own apartment, an own studio. And then during the daytime and so on, when you want to hang out with your friends, you can open and have a big social area in the middle. And this, I would say, is more interesting for example, hotels. So Nordic Choice Hotel has been very interested in this. So in the end of a corridor, you can open up a few walls and create a conference room, instead of producing a whole conference floor that is not used during evenings, and apartments are not used during days. So then you can combine the same area and use it 24/7. Of course, it will look like you use a lot more energy per square meter, but you don't need to buy and produce a whole conference floor. And this is also good for example, elderly care, when you can have an open area during daytime, but when you have visits from your friends and relatives, you can close and have a private moment. So this is how we are thinking that it should be. Right now we don't have the sliding walls. We haven't found the sliding walls that can handle noise and fire at the level we would like, but we're working with Ikano Bostad to try to identify these products. And maybe 2 years from now, we produce 6 apartments instead of 4. But this is also if a researcher or company would like to test, for example, how 10 square meter apartment, how the ventilation flows should be dimensioned, how the window area compared to floor area, and so on, how kitchens should be designed in small apartments and so on. That's something that we can try due to that. Do we have this building permit free area? A few years after that, we might look into really small apartments, but a bigger social area in the middle. And why not go to function units instead of apartments, where you can put the regulation on ventilation, heating and everything into the furniture, and have a big area where you can put your living units in. We have identified a bathroom that is 0.95 square meters, but it's okay with all the current regulations, so you can fold up both the toilet and the sink and so on. So we'll see if we're gonna put that into the living lab in a few years from now. But this is how it actually looks right now. I think this is Axel's without him. So there are the 4 pictures above, they are from the apartments as they are today. And I've heard rather many saying that the furniture on the wall here is not optimized. And I've heard that from the persons living there as well, that it's not optimal. They would like more places to put their clothes, to put their groceries and so on. But I like that it's not optimal, because then I hope that some researcher and company would like to do a research project on how we can optimize storage in apartments. So if you're into that field, please contact me, and then we can do a nice project about geometry and storage in apartments. Not energy storage, but other storage. Then we also have an office and a basement where we can both have the researchers and companies can sit and do research and sit in close connection to what's actually going on. And the basement, it has been a big success. I didn't think about that to begin with, but we have had a lot of visitors from the Canadian Embassy, and we have open house, and we also had the King visiting last week and so on. So it's a quite nice place to have, you know, nice conversations about future smart buildings. So what do we actually measure in these apartments? Yeah, almost everything you can think of. But if you don't see what you think of here, we could add that as well. The idea is that we have an infrastructure that we can do whatever. So the infrastructure can talk all these languages, Modbus, Mbus, BACnet, and KNX, and DALI, and everything. So we can control all flows, we can see all flows. And the idea is that we could do research here about, you know, adaptive control strategies, etc. But if we put very many sensors here, we also have a research project on how many sensors do you actually need to put in to make a good enough control strategy. So I mean, it's not feasible to put in all these sensors in all the buildings, but maybe it's feasible to put in 3 of these sensors in every 10th room in a building in order to make it good enough. So that's one research project that we have. Right now we're working with Schneider systems here to control. So they are trying to find when their system is crashing. So if it crashes here, then they can optimize it, and then it won't happen out in the real world, so to speak. But we're also putting in different side systems to see what systems is best and how can we reach more open source systems. So we're working with Vasakronan and their real estate core and trying to see the benefits of different technical systems to control buildings. And if you would like to do a project in KTH Living Lab, we have a process where you apply on our homepage to do a research project. And a company called Greytech applied to us. They wanted to look how grey water reusage could be a way of handling both problems with resource usage and heat recovery in buildings. So I said to that company, you need to find a researcher that would like to work with you. So I connected that company with David Nilsson on Water Center, and he formed a team with almost 10 companies and Värmdö kommun, and then we also put in HSB Living Lab on Chalmers, and then we after a while got funded. 2 weeks ago we got the answer, 9 million from Formas to actually do research about grey water reusage compared to just heat exchangers in buildings and the system effect these systems have. If you have grey water reusage, you can lower the usage of water up to 60% in a building, and then you don't need to produce a new water cleaning facility, maybe here in Stockholm, for another 20 years instead of 10 years. But if you only extract the heating from the wastewater, then you might have system problems with bacteria in the cleaning facilities and so on, wastewater treatment facilities. So KTH part is to look at the system effects, and the companies are there to optimize their products. Another project that hopefully is going to start in testbed Einar Mattsson in the 305 apartments is to look at behavior, how we can affect behavior in a sustainable way. And here there are theories about nudges. For example, a shower head that turns red after 5 minutes, indicating that you have showered long enough. Or it could be a boost, giving information about if you shower 5 minutes, then it will affect the building like this, on a city level like this, and on a national level in another way. So you get you understand what happens if you use too much hot water. So the idea is to put 40 persons with a boost, 40 with a nudge, and then in a different field, electricity, water, and so on. First, measure how the persons use resources for 3 months. Then measure what happens when you do the interference for 3 months. But the most important part is what happens 3 months after you have done the interference. And that's if you see a change in behavior there, then you know that you have reached sustainable, change of behavior. Another interesting project is with the smart meters that we have in almost all buildings. We could identify what kind of appliance that is used by seeing the electrical signal when it starts. It could be the compressor in the fridge or the coffee brewer or so. But it could also be, if you have good enough sample, it could be that we could see what kind of TV show you're actually watching due to the pixels on the TV that are lit up. So I mean, this is kind of intrusive. So how can we take away this profile? Yeah, put a battery between the meter, the smart meter, and what you're doing. So the only thing that goes out on the grid is charging or not charging the battery. Then you have real privacy, because no one knows what you're doing when you only have the battery. But then Northvolt entered and just, well, we want to rent out the battery. Then we own the data. Okay, so then you just transfer the knowledge from the grid owner to the battery owner. So of course, while doing a research project, you also must think about the business model of everything. So here, maybe if you're a cooperative owning a battery, maybe it's better to own it than to rent it, depending on if you want to be private or not. Another thing when you have a smart building is that you have a lot of appliances. For example, smart taps from FM Mattsson that you don't need to touch, they start automatically, or not, apparently. So these are connected with narrowband IoT. So together with Telia and Ericsson, they're starting a 5G testbed on campus, and then we will also connect these taps to the 5G system. But it's not so easy to connect the building automation system with all the different smart appliances. And I know, everyone has hundreds of apps in their phones, and then you should have the FM Mattsson app looking at how much water you have used. And then the Gustavsberg is up looking at your water profile, and then the Schneider to look at the temperature and so on and so forth. So I mean, here we are starting a project to actually combine all the different systems into one application where you can use all the information also for building management. So all the projects that are performed in the Living Lab, they should somehow be connected to the other projects. For example, when we do projects about allergen-free indoor environments, quite interesting project with Karolinska, where we look how to identify and collect allergens from cats and dogs in apartments. There we use ventilation flows and filters, but the same filter is also used in a ventilation project that we have with Tovenko, trying to increase the indoor quality by increasing the airflow and so on. But then when we start to work with the data there, we need to work with GDPR and integrity. And then we also need to work with the database, how we store data. So all the projects are kind of connected to each other. And that's how we want to work with Living Lab. If you want to do research and not share data, then you can go somewhere else. So if this sounds interesting to you, then to do master thesis or research project or test a product, you can go to our homepage and just apply to use the test infrastructure. And this is we don't have funding. We can, together with you, form a research project in order to get funding. But this is an infrastructure more than a funding part, so to speak. Yes, so here are a few of the companies that are involved so far. So thank you, guys.
Thank you very much, Jonas. Do you have any questions for Jonas? Raise your hands. Yep.
Thank you for that. For the nudges thing you were talking about, have you, after the 3 months of people using it and then 3 months after, observing if change in behavior has actually happened, have you gotten that far, and has anything actually been recordable?
No, the project has not started yet.
Okay.
So the thing is that we've been working to get the infrastructure there to actually be able to do the research project. So that researcher has applied to use the test infrastructure, and we have tried to put the sensors and the infrastructure necessary to make the researcher do the research.
Okay. Good luck.
But the funding for the project has not been okayed yet.
Yeah. Thanks.
So more questions? I'm not trying to throw this one because it usually goes bad.
Thank you. I just have a question about the project you mentioned. So how long do you think if we apply for the project, if you want to be part of one of the research projects, how long in terms of commitment you would require? Because for students like me who are here only for 1 year, we're not sure if we should be doing the project which is a year long or a 2 year long or not. So
I'm sorry, could you please talk a bit closer? Or yes, so I didn't follow.
okay, so my question was how long time commitment do you require from a student who want to work on any of the projects that are there in the Live-in Lab?
Yeah, for students that would like to work with this, I guess most that work with us are master thesis students or bachelor thesis students, and then you have half year to work. So I mean, that's quite often when you're a researcher, you have students working with you, and you know that they are only available for, say, half year or so. But it could also be within courses. So I have a few students in a course that will look at data, and they will only probably work for 2 months. So there is no time limit, just that it fits with the project. So.
Okay, thank you.
Oh. Okay.
How do you apply to live in the Live-in Lab, and what are the benefits?
To live in the Live-in Lab? Yeah, we had it open on our homepage, the liveinlab.kth.se, I think from April to May last year, or this year. And this year, 8 persons applied, because we didn't have it there so long, I guess, and not so many students are looking at our homepage, or it's just not so fun to live there. So, but 4 of the 8 were students. So we said, okay, let's take these 4. Because we don't know what we're going to do research about. We don't have any profiles. I mean, to continue interview persons when we don't know what we're looking for, yeah, felt a bit awkward. So, yeah, 4 persons, 4 students, let's go. But next year we will have the same. We will have it open on our homepage. And hopefully only 4 persons apply. Otherwise I have a lot of work to do. So next year in, I guess, around April on our homepage.
Okay, I think we have time for one final question. I know people have to leave. Anything more?
It's all clear.
Yes. In that case, I would like to thank you, and I just have to back to get something we get for all our guest lecturers. Thank you very much for talking today.
Thanks for having me.
Thank you. Hope you enjoyed.